Oh no. Hello, Skylar. Le- le- Huh? Okay. What? Hello? Oh, where is? Oh, here you go. Huh. Hello?
Hello.
Skylar, can you hear us? Hmm. All right. Let's start with the exercise first. I think we already, everybody is using the exercise, right? Okay. Everybody is here, right? Oops. Whoops. What is this? What's going on with it? Oh, if you don't touch it, it's going to be okay. Exercise review very quick. William, do you have?
Hold on. Two.
Is that right, everybody? Andy, what do you have? Andy?
I'm looking for the answer.
Huh? Okay, Skylar, what do you have? Skylar, are you here?
Yeah.
Can you hear us?
Yeah.
What do you have? This one.
I got two.
Okay. Andy, what do you have? Okay, we have that one. Remember? And yeah. Andy?
Yeah.
What are you saying?
I'm looking for the
What?
I'm looking for the notebook.
For what?
The notebook.
Okay, quickly. We're waiting for you.
Mm.
Okay, you guys don't need to look, okay? I don't have anything. There you go. So fx divided by x minus a. The remainder is always fa, okay? So x13, so a equal 1 here, so x13 plus 1, x equal 1 is always 1 plus 1. So you don't need to look at anything at all, okay? What are you looking at? Huh?
I'm looking for my notebook.
You don't need to look at this one.
Mm.
Sorry, guys. Sorry. Okay. All right, I'm back. Okay. Anyway, the answer is easy. So that one, who has it? How Dyla? Oh, the root. That's
I
the
have
root.
3.
Yeah. Gosh. Root.
I have 3, negative 3/2, and then 3 plus or minus square root 19 times I over 2.
Okay. So what do you have, Andy?
Okay.
Huh?
Okay.
20?
Yeah.
Hey, where is that? Right.
Hmm.
There you go. No, not that one. Where is it? Where is my stuff? Huh? I lost my stuff. Here we go. All right. Okay, here we are. Okay, root. A lot of misspell. I'm sorry. Oops. What's happening? Okay, so that one you only need to test. So Skylar saying you have 3 and minus 2.
No, no, 3, negative 3 over 2.
Oh,
And then,
okay, as long as you get those two, then the next should be something square root of something.
yeah.
Should be easy, okay?
Yeah, I got a 3 plus or minus I square root 19 over
So,
2.
William, you have the same thing?
Yes, except for I didn't bother to find the two complex roots.
Okay, that's fine. As long as you know. Okay, so the next one is, huh? Where you get that one in? I lost the slide. There we go. Find a values of m infinite that as a factor of, that should be straightforward. Andy, what do you have? Andy?
I didn't really do this one.
Huh?
I didn't do this one.
You didn't do this? Don't know how to do?
I know how to do this.
Huh?
I know how to do this.
Why you didn't do?
Hmm.
Huh? Huh? Andy?
It looks easy, so I didn't do it.
What?
It looks easy, so I didn't do it.
Okay, do it now. I'll give you a minute. Okay? Oh. 我也是呢啊。Give you a minute. Quick, we're waiting for you. What do you have? Huh? That long? That's too long. Mm-mm. All right. So okay. You can write your answer. What is it, Sandy? Did you get it? Okay, so Andy obviously forgot everything. Okay, so Andy, if you cannot send in 5 seconds, we're not waiting for you anymore. Okay. Okay, William, your turn. William?
I got m equals -1/2 and 2/3.
Yeah. Okay. Okay, 1/2 and 2/3. So. Is that right, Skylar?
Yeah, that's what I got.
Good. What is this? Skylar, you have it?
Yeah, I have -1 to the n plus 1 power.
Huh? Okay.
Yeah.
Because that's simple, okay?
That's why I got.
Yeah, because that's simple. Okay, you get okay. That's fine. So the next one, the equation x for okay, where is the next one? 4x to 4 is x to the 4. I'm sorry, x to the minus 15 plus 94. Oh, that's totally wrong. That's totally wrong, right? Huh? That's totally wrong. Totally wrong. 94. Oh. 90. What? This something. There we go. Andy, do you have an answer for this one? And yeah.
No.
No?
No.
Do you want to try?
Four.
Huh?
4.
You know how to do?
Yeah.
Okay, do it. There's so many misspell. I didn't really get time to check on that thing. That's the problem. Misstep. All right, I think if you didn't do it pretty hard, you also probably don't. I'm not sure you know how to do it. By the way. Okay. There are a bunch of ways to do it. Let's check the answer. So William, you have the answer already?
-15.
Yeah, I think we did it before. Everything we did all this before. So Andy obviously didn't get anything for it.
No, I think
Yeah.
you asked us to do them and then we didn't go over them in class.
Yeah,
Okay.
we didn't go over these.
Okay, now it's good. Okay. Gotta get something.
Yeah.
That one, let me tell you how to really how I think about it. You can do like a very trivial and using x to the 4 minus 16x to the qubit plus 94x squared. Okay. Then plus px plus q, because all the root is double root, you can assume it. For example, it's x squared plus x plus b squared. Then you just find the AB will be that. Because you compare the cubic, then get minus 16 to 2a. So a must be equal -8. So you change it, then you change the series can be changed to be -8, right? Then you compare the quadratic terms, so you get 94 equals to like 2b plus 64, right? You get b equals 15. Then you get, basically you get q equals b squared 25. Then t equals to, then the x term will be minus 2 times 8 times 15, right? So t plus q, negative 15. Okay? Good?
Yeah.
Yeah.
You have many ways to do it. Don't have to be that way, but then turns to be like
This way was much faster than the way I did it.
Okay.
Yeah, same with me.
Okay, next one. Probably a lot of misspell for the slide because I didn't really get time to check. So ax7 plus bx cubic plus cx minus 5. So if f minus 7 equals 7, then what is f7? Let's check with William.
Negative 17.
Okay, so what do you have? Andy, do you have any? Andy, yeah.
No.
Oh, you don't have any? Okay, so we skip you, okay? So, okay, Skylar, same thing?
Yeah.
Okay, next one. 8 to 0. Actually, this problem is pretty confused. They still have 3 roots, but the 2 of them add up is 0. Then ask you what is b over 3. Skylar, what do you have?
I have -3.
Okay, the same side, William? William.
Hold on, I'm looking.
Yeah.
Yeah, I think I got -3.
Okay, so move next. The equation with the root. Then you find a plus b plus c. This should be straightforward, okay? You can construct the equation. Maybe we don't need to look at it. Have problem?
No.
Check it anyway. So what do you have, William?
$35.
Okay. I think it's maybe polynomial px contains only terms of other terms. So when divided by x3, the remainder is 6. What is the remainder when divided by x for -9? What do you have, Skylar?
I have 2x.
Do you have, William?
Yeah, I have 2x.
Okay. So that's one. Or the coefficient integral. So because both show that there's no integral solution. That one is probably not that straightforward, huh? So let me doing that thing for you, okay?
Yeah, I was slightly confused with this.
Okay. So you have A0 then AN plus A0 or I. Okay? That's all same. So which means that's the same, right? So means if AN xn plus AN minus 1 xn minus 1 plus plus A0 equals 0 if has a root. The root you can assume if x odd, you can say odd, okay? So modulo 2, both sides of modulo 2, you find AN plus a minus 1 plus a0 equals 0 modulus. Oh, x is odd, yes, right? So this is impossible because this is odd. And originally saying this is odd, so this add up together cannot be that way. Okay? If x is even, right? We modulus again, you get a0 modulus. Okay? So this is also impossible because saying a0 is odd here. Okay?
Yeah.
Okay, that's all good. Next one. And x4 plus blah 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 is exactly divided by it. Then find p plus q plus r. That should be easy too because that's only division, okay? That's easy. Anyway, check it anyway. What do you have, Skylar?
I have 15.
Is that what you have, William?
Yeah, I have 15.
Okay, next one. RST x cubic minus. Okay, find the dash. What do you have, William?
I was confused with this one.
Okay, so what do you have, Skylar? There?
Negative 59 over 49.
Oh, okay. Okay, let me do in that one for you anyway. Okay, so I think this Skylar probably right. The answer probably right. So last time we talking about if fx has a root r, then fx essentially, so I want to have then you multiply it. In this case, multiply with 3, then has root 1 over r. Okay? So we can flip it first. So in our case, original equation was x cubic minus 6x squared plus 5x minus 7 to 0, right? To flip it, you get minus 7x cubic plus 5x minus 6x minus plus 1 equals 0, right?
Yeah.
So assume this one has a root, actually is u v w, which is exactly as 1 over r, 1 over s, 1 over t, right?
Yeah.
Okay, now I ask you to calculate. You can rewrite as this as then we want to calculate u squared plus v squared plus w squared, right? So you know how to calculate this. That's the thing, right?
Yeah.
Do you?
You just used whatever. What did they call before? Newton's principles or something like that. Newton's sums.
Yeah, you can use in that. I actually, for me, to tell you, I hard to remember that thing. I almost don't remember that thing. I using one principle in my head is called every symmetric polynomial of that already the root, then you can write whatever the symmetric. I told you that already a long time ago. You can write the polynomial of the something called fundamental symmetric function of all roots. So if you have u, v, w, then we have u plus v plus w equals 5 over 7, right? I have UV plus VW plus WV, and UV W U equals to 6 over 7, right? They just using that will be enough. So that one you can simply write as U plus V plus W squared minus 2 UV plus UW plus VW. Okay? Then then just plug in that all about. So 5 over 7 squared minus 2 times 36 and 49. What? There is no square here. There you go. So whatever this number is, let's get 25 minus okay.
Okay.
Newton, that formula is essentially the same thing, okay? That one just help you to figure out what's there. That's all, okay? If you know the algebra very well, then you know. That one is easy. So that's also proved. Just check the conjugate will be enough. Let's move forward. Next one is Andy, did you find your notebook?
No.
Do you have one? Huh?
No.
Huh?
I did.
Okay.
Mm-hmm.
Whatever. Skylar, do you have this one?
Yeah, I have negative 1 over 16.
Same.
Okay, then move to the next. That was pretty easy. So solve that equation. Who has it? Yeah. You have this one?
Negative 5 plus or minus square root of 5 divided by 2. Everything divided by 2.
Yeah. Let me write down. I don't really know. Actually, I don't know the answer on that one. So
I got negative 5 plus or minus square root 5 over 2.
okay, let me write down. Skylar, what do you have?
Negative 5 plus or minus square root 5 over 2.
5 over 2.
I don't know, it's just square root 5 and then the whole thing over 2.
Like this? Huh?
Yeah.
Okay. That actually is a pretty interesting problem. You see, x plus 1, x plus 2, x plus 3, x plus 4 equal negative 1. So you want to multiply that one first. So you get x squared plus 5x plus 4. Then you multiply those two together, you get x squared plus 5x plus 6. So you get x squared plus 5x plus 5 minus 1, then plus 1. So it's using difference of 2 squared. Oh, right? Right? You get,
Yeah.
so whatever it is, so minus 5 plus square root of minus 5. Okay. happened?
William disconnected. I think he's trying to fix his microphone or something. Not sure.
Huh? What happened? That seems good, right?
I think no. I think William's trying to fix his microphone.
William?
Okay, I think his microphone is broken. I think his microphone's broken.
Break?
Yeah, he's not in the call.
Is he back? Technical issue. You know, your oh, okay. Can I hear anyone? Okay, I'm waiting for you. Yeah, that's the problem. Ay. Okay. Okay, here it's back.
Okay, I'm just using a phone now.
Okay, good. Yeah. I was just trying to tell you there is a phone number actually you can call. I forgot what the number is. If that's not in mind,
They tell you what the phone number is.
yeah, okay. That's cool. So this one should be easy, right? Actually, I didn't really when we learned the choose function, we didn't really explore too much. Similar thing already happened with this function. But anyway, for that one, who has it? Skylar?
I got X.
X?
I think. No, wait. Wait a second. I think. Wait. No, that's wrong.
I think you mean 1.
Yeah. All right. Yeah. X equals 1.
I know. Let's see. What do we have?
I'm not sure. I don't think I. Yeah. I don't think I finished this one. Never mind.
What happened? Oh, this one is. Oh, actually, we should learn how to use that one. I never tried, but this looks like terrible. See? Pretty hard to use. Okay, anyway. Oh, now this one is shared, right?
Yeah.
Huh.
Yeah. This is shared.
Okay. It's pretty hard for me. I don't know. We need to learn how to use. Also in your you should have somewhere like raise a hand, something like that. You want to say something? Anyway, we can just send directly. You can inform me anytime if you feel like saying something not clear. Okay. Okay.
Okay. Okay.
So because sometimes it's just okay. This is very basic trick, but we didn't really talk about it. So 1 plus x plus x squared then to the n. So must be equals to a0 plus a1 x1 plus a to the n then x squared. Right? So you just let x equal 0, x equal 1, x is equal 1, okay? Then you get 3 to the n equals to a0 plus a1 plus a2 plus a2n. Okay? Then you let x equal minus 1. Then you get 1 equals to a0 minus a1 plus blah blah blah. Then find this last one is 2n. So all other terms is going to disappear, okay? When you add up together those two, all the other terms go. So 3n plus 1 is going to be 2a0, a2. That's all. Okay, the answer is going to be 3n plus 1 by 90. Right? So next one should be easy. And we don't know what is it. So that one you just directly divide it. That's only 2 polynomial. Should be able to do it, right?
Yeah.
Okay, that one is funny. Prove that root of x squared minus 4x minus 2 equals 0. Also, every root is the root in the equation above. Then solve the original equation. Who is it? Skylar.
I got 2 plus or minus square root 6 and 1 plus or minus square root 5.
I think only saying factorize that won't be enough. Okay, so just the proof is very important. As long as you have the proof, then you're going to have then you're going to have then you're going to have x squared minus 3x minus 2 squared minus, I think it's 3 squared minus 3x minus 2 minus 2 because 0 is going to factorize that x squared minus 4x minus 2 times another x squared blah blah. So the key is you prove this is a factor of this. This is the key. How do you prove it? You can do it that way. You let what? Let t okay. Then you have x squared minus 3x minus 2 to t plus x. Then you plug in that one into this one. So you have t plus x squared minus 3 t plus x minus 2 equals 2t to the square plus 2t x plus x squared minus 3t minus 3x minus 2. You put t together, you get t squared plus 2t x minus 3t plus 3x squared minus 3x minus 2. Right? You doing right? Huh?
Yeah.
Wait a minute. T squared plus 2tx plus x squared minus 3t minus x minus 2.
Yeah, that seems right.
T squared plus 2tx minus 3t. I think it's wrong. The minus x minus 2. Oh, we are missing something. We're missing something. Here's the minus x. Okay? This is the original equation. The minus x. Okay? Original has the minus x there. So you have the minus x here. So here become let's throw that again. Yeah, this is doing something wrong. No, this is my local computer. Right, like that. There you go. Okay, here is the t again. Okay, it's another t. So you get t squared plus 2tx minus 3t minus 2t. Right? So you get t as the one factor, then t plus 2x minus 2 as another factor. So the two factors, one is t, another one is x squared minus 4x minus 2 plus 2x minus 2. To become x squared minus 2x minus 4. So that is another factor. That is two factors. One is that, one is that. Minus 4x minus 2 minus 2x minus 4. So as long as you know that, then you solve, it's easy to solve, right? We have proved equals to x squared minus 4x minus 2 times x squared minus 2x minus. Okay? Correct?
Yeah.
So you basically solve this one for 0, this one for 0. That's all. That's pretty interesting question. Okay, very interesting question. Very tricky. Okay, next one. William, do you have it? One o two. Let's see the question. To find the p, find the polynomial which satisfies px equal px to the k. Huh? You want me to do it? William? William, are you there? Let's see. Yeah, you are here. William.
Quick. Now can you hear me?
Yeah. You have some trouble? Okay.
Yeah. I couldn't do this one.
Okay. Okay, this one is pretty easy actually. So basically it's saying P to the Px equals to Px to the K, to the K power. So you have two cases. So one case is, so Px can have only finite is a constant. Okay? If Px is a constant, then it's easy. Then case 2, then Px is not constant. So equal at least some x term. So Px can have infinitely many values.
Yeah.
So if that one is the constant should be easy, that one then can only be Px can only be x to the k. Okay? Because infinite many value. Next chapter we're going to learn functions. If two functions can have infinite many value at the same, especially if it's a polynomial, they'll be same. So Px minus xk can only have finite roots that have the infinite many, then it's going to be equal, identity. So the first one is easy, constant, so C, right? You want me to figure out? Continue?
Yeah.
Okay. So if Px is constant, x equal to the C for some constant C. So then you have C in this end, then equal C to the K. So you are essentially the K already tell you is already dependent. So can only either C equals 0 or C equal something. is k minus 1 equals to 1. So c equal 1 or minus 1. If k is odd. So we have three cases. 1.1, k is odd. Then you have the two solutions. So px can be 0, can be 1, or can be minus 1. So 1.2, k is even. Then px can be 0, can be 1. That's all. Okay? So you have another case is px equals to x. Let's directly get it. Okay?
Okay.
Next one looks like very hard. Very hard. We did that already. Did it last time. Just review it right now. Okay. What do you have, Skyler, with that one?
I wasn't able to finish that one. I can do it.
Okay. What do you have, William?
3x to the 4 minus mx to the third and then minus 1.
What is that? Say one more time.
3x to the fourth minus mx to the third minus 1. Or am I reading the wrong question?
So we're on the 103.
Yeah.
If A, B, C, D are find the polynomial. Okay. With the leading coefficient 3. Oh, okay. I'm sorry. I thought somebody. What do you have? You have 3x.
3x to the fourth minus mx to the third minus 1.
I see. Probably right. Yeah. Probably right. That's why actually look at part, but it's very easy because a plus b plus c over d. Because a plus b plus c equals 0, that's over d squared. So this is actually the minus b. Then it's d squared. So it's minus 1 over d. So you just flip, then negative, that's it. So I think you're probably right. Let's just flip it. So m to the 4 minus, I'm sorry. How does one behave? I think my computer is kind of weird now. You start with the question. Question is x to the 4 minus mx minus 3 equals 0. Then you have flip it to get 3x to the 4 minus mx plus x minus 1. Then you take the minus, you get minus x. I think you're right, okay? You're right. Now we come to the last question now. For n is greater than 1, let a1, an be n distinct integer. You can think about 1, 2, 3, n. Then prove that the polynomial cannot be written as a gx, hx, one gh, whatever, a polynomial. So one of them is not 1, okay? That's the whole point. Get it? Also, it's not 2, not then. It's the polynomial. It's a very very important trick for the future. You trying to find some polynomial, which is something like a prime polynomial. You know, cannot decompose. Understand? cannot decompose pretty much means it's already irreducible, something like that. So let's see together with that one, okay? I think something is frozen with my thing. There we go. All right, here we go. If you have one, assume that one can be divided as hx, gx. Okay. Then you let x equal a1. You get ha1. So we all assume is all have the integer solution, integer coefficient. Okay, that's the assumption. So ha1 times ga1 is going to be -1, right? So ha1 is going to be negative ga1, right?
Yeah.
So you can assume degree saying g is less than half, right? One of them must be at the most half one. So you have ha1 also hai, same thing equal minus dai. So if you look at that polynomial h plus g, it has root a1, a2 to n. So it has the n root. But the polynomial at most has degree n -1, right? So both of them have degree less than n -1. So h plus g is going to be 0. Identity is identical to the 0. Okay? You understand the logic here? A polynomial. Is a polynomial
again?
Okay, so h and g. Okay, let me explain to the next page. Okay. So fx equals to x minus a1, x minus an minus 1. This is a polynomial with degree n. Then equals to hg. Hg we assume none of them is constant. So the degree g or degree h at least be greater than 1. So means degree h will be less than n minus 1. Also degree g is going to be less than n minus 1. Right? So we also have h plus g, this polynomial, as ai equals 0, or I equal 1 to n. Right? Right?
Yeah.
Yeah.
So
Yeah.
h plus g has degree at most n minus 1. But has root a1, an as a root. So a polynomial has the degree at most n minus 1 then has n different roots. So the only possibility is h plus g has to be 0. Got it?
Yeah.
Okay. Andy, are you there?
Yeah.
You get it?
Yeah.
Yeah? Okay. So, which means h equals minus g, okay? So means f equals to, sorry, not saying f, I'm saying that way. So saying x minus a1, x minus an, minus 1 equals to h d minus g squared. Right?
Yeah.
Okay.
Then will be interesting. So anyway, so n has to be odd, n has to be even. Then minus g squared. Okay, let's move to the next page. That will be impossible. Why? You take x equal a1, you get minus 1 equal b squared minus b squared, huh? Right? So g squared equals to 1. So which means GAI equal 1 or minus 1. Right?
Yeah.
Yeah.
Probably I should say GA1 here. GA1 equal 1 or minus 1, then have GA2 equal 1 or minus 1. Then till GAN equal 1 or minus. Right?
Yeah.
Yeah.
So you have, so you look at here, because G, N must be even, by the way, okay? N is even, must be, okay? Otherwise it will not work, right? So among all the N, A1 to AI, so must be half of them make the G equal 1, then half of them make G equals to, so G, then GA, we can assume GA1 to GAN over 2 equals to 1. And just rearrange that and you figure not, okay?
Okay.
Okay?
Yeah.
Okay, so basically the half is going to say G minus 1 is going to be x minus A1, x minus A, 2, right? Yeah,
Yeah.
going to imply that. The second one is going to be imply G plus 1 is going to be. So this is already a problem. When you have the that one, you plug into the x equal to a pretty big one, saying an 30 problem. You see it? All right.
Yeah.
30 problem. So you say G essentially equals to G equals to 1 plus x minus a1. X minus a n over 3. Then you took some a n. Let's say a n is pretty big. A is greater than everything. All pretty. Maybe not really. Anyway, you plug into the a n to see what happens. Dn is going to be pertain to us. It's going to be minus 1 is going to be 1 plus x a n minus 1 a1. Sorry. So a n minus a of n over 2. This one is going to be 2. So those many values multiplied together. So because they are all different. So if so means it's already equal to minus 2. You take something big enough, it's going to be a problem. Rearrange the order. You see the problem? Also, yeah, we can do another way. So same deal. You don't really have to remember that. You same deal. You can get Cx equal minus 1 plus x minus a n half plus 1, then till x minus a n. That thing cannot hold. Okay, that thing cannot hold just because a1 to a n they're different. Cannot be that way.
Yeah.
Okay, so let's say y cannot be that way. Say if 1 plus x minus a1 x minus a n over 2 equal minus 1 plus that x minus a n over 2 plus 1 to x minus a n. If that thing holds, then let's take maybe the wrong thing. We take something biggest, okay? Biggest a. Assume a n is the biggest, for example, okay?
Yeah.
A n is the biggest will definitely be wrong because 1 plus something positive, then will become minus 1. That will be wrong. Right?
Yeah.
Actually, anything here, if the a1 is the biggest, then 1 will be minus 1, 2, then x times that, because it's different. So positive can be only 1, 2. So that one will be n can be only the biggest, so only 1, 2. So the smallest one is in the You see the problem? And I'll recode it. Okay, we can do. And let's see what's my solution there is. I think that we are using something better here. Maybe wrong actually. So we have fx equals minus h squared. Oh, okay. Yeah, and so we don't really need to say it. I'm so sorry. So that one, you take x is big enough will be problem. Do you know what I'm saying? When x is big enough, let's go back again. So here, kind of frozen. I will need to restart my computer in a second. So here again. So here, this line, okay? We take x big enough, then the left side is positive. X big enough, positive. This one is negative. So it cannot hold, okay? Okay? So
Yeah.
X don't really need to big enough. X equal n plus 1, and everything adds together is already enough. A1 plus A2 plus n already enough. Anyway. Okay, let's calculate the complement break. I think last time I didn't realize that we need the break. Then we go over to the function. Okay?
Okay.
Okay.
Right. Let's see. All right, we're back. Mhm. All right, everybody back?
Yeah.
Right, function. Function. Right. Skyline back. Skyline not here.
Yeah, I'm back.
Okay. Okay. Usually we talk about functions and function is from a real number to the real number. Okay. But sometimes you are talking about from like natural number to the natural number. For example, can sin x is 1. Then, for example, say you can have like 2 to the x. It's from integer to integer, from positive integer to positive integer. Okay. So in the future, probably we can have something from complex number to the complex number. Sometimes we can from one piece of, like say from 3 to the 4 to something, maybe to the real number. Anyway, this is just a function, okay? Let's see, I have, what is that? Not that one. Okay, so that R means all real numbers, okay?
Yeah.
That's kind of simple. So this is the notation. So we already learned a polynomial as a function. Then we learn a bunch of functions like sine, cosine, log, then 2 to the x, e to the x, and e to the x minus e to the minus x, for example. Also, we talk about a function as a domain, a range, like saying sine x. What is the domain of sine x?
All real numbers.
Domain is R. So what is the range?
Negative
+1 to -1. Yeah.
Included, right?
Yeah.
Yeah, actually in the entry test, when you test a lot of the log x, right? What is the domain of log x?
0 to infinity with 0 not included.
Okay, so log x, like log 2 to the x. Then the domain actually is x greater than 0. But if you have log say, x, then the x plus 1. So what is the domain of this one? So that one cannot be 1. So x cannot be 1. But that one also has to be greater than 0. This one also be greater than 0. So actually that's all the domain. So x greater than 0 x not equal 1. As long as it's greater than 0, x plus 1 is greater than 0. Okay? So if you have that function log x in 2 minus x will be little bit complicated. Then that part will become x less than 2. So will be 0 less than x less than 2, x not equal to 1. Right?
Yeah.
Yeah.
Andy,
Yeah.
What do you think?
I say yeah.
Okay, so graph. Also graph is, I didn't really teach you guys very much about graph, but graph is very, very important. Like log x, you should have the graph of log x in your head. So that's basically log x, log x. Maybe say log 10 to that, log 10 to that. For example. That's the graph of it. So sine x, we already learned that, but I think we didn't really talk about it. Okay. Graph is good because they combine the domain and range together. You can see all the range and all the thing, everything. So also a lot of functions I just would talk about is then from natural number to natural number. Actually, the MC a lot. You can talk by add number, add function, right? Add function is like that. Then like sine x, then x to the cubit, x to the other degree is the add function, right? F minus even function is f minus x, right? For fx. So like cosine x, then e to the x plus e to the minus x, right?
Yeah.
Yep.
That's just a review. You should have that image in your head already, right? Okay, now then to leave the exercise. Which one is the add function in this picture? Which one? Okay, you tell me the answer. Maybe write it down. How do I get back? Okay, let's see the answer. What is
What were the functions again?
that? Let's see it again. Okay, maybe we are continue till okay, just saying it. Don't need to write it. Andy, what do you say? You think?
Is it the second one?
Anything the second one? Okay, Skylar, what do you think?
Third one?
Third one. So William, you think the first one?
Should I? I think the third
Maybe.
one. I'm not.
Yeah.
Is there one that's odd?
Huh?
Is there one that's odd?
One question?
Never mind. But
I don't think any of them are odd. Or I'm just misreading something.
What's going on here? What's going on here? Okay. So you verify. Okay. Change sine x plus 2. You put the minus x to sine minus x. Would be minus sine x plus 2. They're not equal. So x squared minus x plus 2, I don't remember. Then put minus x there, then get x squared plus x.
I think it's plus 1.
they're not equal. So the last one is 2 to the x, then put the 2 minus x, they're not equal. So none of them, okay?
I was right.
I was not. I must type something wrong, okay? Oh, anyway, I must type something wrong. Supposed to have it.
Wait, you did minus x plus 1.
Yeah, that's okay. That's okay.
It's not really important.
That's it. Yeah, that's okay.
Okay.
Right? Okay, you're also talking about something called injective. If fx equal x, fy implies x equal y. Or in other words, if x equal y, then fx not equal to y. So injective usually means just going up, going down. Never saying going down, then up, up, then down. Okay?
Isn't this basically 1-to-1?
No, 1-to-1 actually is we are going to have it. So example, x plus 1 is injective. E to the x is injective. Fx log x is injective, but fx sine x is not. X squared is not, because x squared will be like that. Okay, then sine x will be like that. So when you hit 1y with the couple of value, then it's not injective. Okay. So also called surjective. If for every y 0, then we can find x 0 such as fx 0. For we're talking about the real function to real function, then x plus 1 is in a surjective. Fx equal to x cubed is surjective. Fx is log x of. So, but sine x is the e to the x, e to the x so 1-to-1 means both surjective and injective in the domain. So actually saying log x will be the 1-to-1 in the region when the x greater than 0. But in the whole region, in the domain, okay, it will be okay. Example, fx equal x plus 1. Which one is 1-to-1? Now another question. Which one is 1-to-1? Okay, 1-to-1, I skipped already using the definition. 1-to-1 in the domain. So as long as defined under to the region, then 1-to-1. As allow 1-to-1 allow you to have only piece of interval to piece of interval. Doesn't have to be the whole real numbers. Which one is 1-to-1? Now this time,
The third one is.
Guy last name first.
Yeah, I think the third one, definitely, yeah, the third one.
What is saying this?
Probably third.
What are you saying? Okay, as long as you have square, it will not be injective. Okay. For example, you can have
I thought we were asking for 1-to-1, not injective.
well, injective. So one-to-one is both injective and surjective. It's one-to-one. Okay. One-to-one means both injective and surjective. One-to-one. Okay, so you have one from the domain, one from the range. That's what I mean. Okay. So now
So
the definition.
the first one?
Yeah, actually the first one is. We're going to learn this one in a minute. Okay. The first one is. The next thing, the composition. You can define two functions composed by just the type one after another. So the domain might change. We learned the log that thing, right? That composition, then make the domain change weird, right? You remember?
Yeah.
Okay. So this is where the tip is coming from. So you also define F2 to be the, I think there's no parentheses probably. And no parentheses. I think there's no parentheses. I cannot remember now. Let's see. Let's see, it's F and yeah, okay, there is F and yeah, both probably okay. Okay, both are okay. So F0 is identities. What is identity? So identity is right. Remember, identity function is mapped to everything itself.
Yeah.
Yeah.
So then we define something called identity. You see, the composed with anything, still that thing. Anything composed with identity, still that thing. So we also learn the concept called inverse. If G and H inverse is one for whatever the domain, okay? Example, Hx equals x plus 1, then plus 1, then minus 1, then will be the sin x and e to sin, okay, sin x arctangle, arc sin x, that's in log x, e to the x, that thing. So we also prove that thing. That one actually is proved in the book. If you forgot it, you can look at it on the page. Where is it? Somewhere. Where is it? Oh yeah, it's just example 7-1. Okay, 7-1. If G is the inverse of F, then F is also inverse of G. Okay.
Yeah.
Yep.
Okay, so this example find its inverse. How do you do it? Just using brute force. Say plug in, yeah, one set. That's a little bit probably forgot. Yeah, it's in the book. It's in the book.
Yes, example 7-2.
You say FG, then X is going to be GX, 1 plus GX. You map it to be X, that's all. So GX going to be X plus X times GX. So GX going to be X and Y minus X. Right? You just assume GX.
Yeah.
Let's find that. Just solve it. That's all about. So the okay, the exercise 7-1. Do you still remember the solution?
Exercise?
Yeah, exercise dash 7-1.
Do we even need to remember it? Can we just do this in our head?
X cubed.
We can do now.
X cubed.
Yeah, it's x cubed.
Okay, that's it. Next. Okay, I give you another exercise. Find it. Find the inverse of this function. Where is it? You can, let me see. Okay, write down the question. Then I ask you to write down the answer. Okay, so we have Skylar has it. Okay. Andy, Skylar, William, everybody different, okay? 3 people all different. I don't know who is right, okay? See your answer. I show you. That's all your answer. So Andy has 1 minus 3x. Skylar has 3x minus 2. William has 3x minus 1. So which one is right? I don't know.
Wait, what's Williams over?
Huh?
What's the denominator of Williams?
You cannot say it?
No.
You see it?
No.
Huh? Can, oh, yeah. Hey, you can see now. Should be able to see my screen. Right?
There's no
Just see the-
answers.
Yeah, we just see the latex. Dude.
Yeah, we only see latex.
Oh, see later.
Yeah.
What happened?
Wait, what's the denominator of Williams?
You see now? Still cannot?
This is x plus 2.
2
Alright. Okay, I will tell you.
If the denominator of his is 2 minus x, and we have the same answer.
Everybody has 2 minus x anyway.
Oh, then we have the same answer.
Oh,
Because
yeah.
minus
Okay.
x minus 2.
Okay, Andrew and William have the same answer. So now Skylar, we down to your answer now.
Oh, okay.
X is 3x minus 1. Or 2 minus x. Okay, that's right. Okay? That's what it is.
Okay.
Okay? Why you get wrong? What's wrong with it?
Not sure. I'm redoing it right now.
Okay. After you're done. Good. All do together. Bella.
I'm almost done.
Oh, now we see that thing again. This one I cannot read. I don't know how to use them. Oh, try this. Oh my gosh, it's so big. Why is so big? Oh, this one probably. Huh. So I don't really like it. So let me going back. Okay. Hmm? All right, William, you got it? Sorry, Scott, you got it?
Yeah.
Is that same as that?
Yeah.
Okay. So functional identity, this is very, very big topic. For example, log x, okay? Satisfying fxy equal x, fx plus fy. So you can prove that if fxy equal fx plus y, if xy fx times y equal fx plus fy, then fx essentially is log x. But you have to use in some usually calculus a continuous function. Right? Also, we have the EX satisfying functional equation. Who know what it is? You have F whatever. What is that one? Satisfying. Equals to, okay?
Yeah.
That is satisfying. Actually, you can prove that if satisfying like this, then essentially is e to the x. Okay, let's see a little bit the exercise. Do you remember it? 7-4, 7-5. 7-4. Okay, trigonometry also satisfies some equation. That's about sine x, cosine x. That's okay. It's essentially is that one. I can tell you. Essentially is sine. All right, animal. I think I changed the color. No, I didn't do anything. Huh? Oh, okay. Wow, that's very slow. So essentially is sine x plus y, that formula. Also sine square. So nothing really. So 7-5, let's look at 7-5. Which of the following functions identity are satisfied by fx equal absolute value of x? What do you guys think?
All three.
The first one is?
William saying the first one. Skylar saying What you saying?
I say all three.
All three. 1, 2, 3. So Andy, what do you think?
I think I think all three of them.
Okay, let's do together. So
Wait, never mind. Wait, never mind. It's only the first one.
the first one.
Yeah, never mind. Yeah.
Andy, what do you think? You cannot really
Oh,
call.
number 2, x could be negative or y could be negative. Something could be, yeah. Mm,
Okay, the second one.
Second one doesn't work.
Not work, huh?
Nope.
Yeah, same with the third one.
Do you know anything about the second one?
Alright, third one, x can be negative.
Okay, assume now let's make it simple. Assume f is defined, just defined on the rational number. This is the rational number, or the fraction, like 1, 2, 3, something. Okay. Then assume f1 equals to 1. Then what is f? Do you guys know? A constant? Constant. Can be constant? Constant has to be 1. Then 1 equal 1 plus 1?
Never mind.
Okay, let's do it together, okay? So you have fx plus y then plus z equals to the first one plus the second one equals fx plus y then plus fz. So it's going to be fx plus fy plus fz. Right?
Yeah.
So you're going to have fx1 plus x2 plus xn is going to be fx1 plus fxn. Right?
Yeah.
That is going to be so fx1 plus is fx1 plus. Okay, if I let x1 equal x2 equal equal xn equal, for example, t. Okay? Okay? Then have fnt equal nft. Right?
Yeah.
Yeah. Yeah.
So
Yeah.
you let t equal 1, then get fn equals to n. Right?
Yeah.
Okay? So all the integer you map to yourself. If you let t equal 1 over n, then this side is 1, then this side f, and then 1 over n. You get f1 over n equals to 1 over n. Right?
Yeah.
See? So if let t equal 1 over m, then you get f n over m equals to and then f 1 over m. But we already got the 1 over m, so it's so that's it. So rational, every rational is right? That good?
Yeah.
Yeah.
Okay. That's interesting. So f of x equal x. That's also interesting. Let's look at it. I didn't really see it. So now we said so f x equals to x. So what is kind of x would be like this? Huh?
Inverse.
Yeah, what is that? Huh? Actually, there are a lot. For example, fx equals to, you give me some example.
1
fx
over
equals, what do you say?
1 over
One
x.
over x is good. 1 over x and 1 over x, that's good. So who else has an example? Okay.
Log x?
Log x not good. Log x would be log. Okay, y minus x good. Okay, so fx equal y minus fx to y minus x. Okay,
Yeah.
who else has an example? Huh? Who? Okay, 2 minus x is also good. Okay, 3 minus x is also good.
N minus x.
Minus x, not good. 1 million minus x. What else do
N
you
minus
have?
mx.
Huh?
N minus m.
Y minus 1 over x? Is that good?
What? No.
No.
It was 2 over x.
Okay. Okay, you go back to find the one more example, okay? Okay, next one is also interesting. Exercise 77.6. Say find that the floor function satisfy fnx equal nx. You know what the floor function is?
Yeah.
Yeah.
The floor function is like 3.14. The floor is 3. Minus 1.5, the floor is what is the 1 minus
Negative
1.5?
2. Negative 2.
Okay. That is when satisfy fnx equal nfx. What's your answer? Yes or no? The question is clear.
Yes.
Does floor function satisfy for every x? You say yes.
Well, For all integers, it's yes.
I'm saying yes.
Wait, for all integers, I thought.
What is
Yeah,
that?
for all integers, yeah.
What is Andy saying?
For all,
Is this for all
For number
integers?
1 and 2. For number 1 and 2, yes. For number 3, no. I think.
Yeah, 1 and 2 work. 3 doesn't.
Yeah, 3 doesn't work.
Okay, you saying 2 work? Okay, let's n equals 10. Okay? Good. Then x equal 1/2. So the left side is 5. So the right side is
0. Only one works.
huh?
Only one works.
Only
Yeah.
one work. Yes.
Yeah, only number 1 will. Oh, 2 and 3 don't.
All right. So okay. But more in the future, okay? The identity. Pretty much with the functionality. I'll just give you this example. Find all the actually it's monotone. Doesn't have to be monotone. I didn't really talk about it. It's an increase in monotone. And we should know this word, okay? Means if xy is greater than x2, imply fx1 greater than fx2. Okay? That's monotone mean. That's why that's actually for monotone, we don't really have it. I just did exactly this one. See? Right?
Yeah.
Okay.
Yep.
That's interesting one. Let's finish this example, then we are going to finish this thing. Let's talk about vector function, fixed function. Yeah, I think that's all about it. So this is an example. It's interesting. If say a function satisfying this, then ask you to find 2015, the value at 2015. I guess you have no idea. Anybody have an idea? Maybe.
Not really.
Okay, the whole trick is you switch x by 1 minus x. Then you immediately get this. So x squared plus x and x squared minus 3x plus 2. And you switch x by 1 minus x, then switch. Okay? Let's see it. So x squared plus x. When you switch to 1 minus x squared plus 1 minus x, then become x squared minus 2x plus 1. This x plus 1 become x squared minus 3x plus 2. And because 1 minus x is the inverse itself, so x squared minus x, 1 switch, then get x squared plus x. Okay? You get it?
Yeah.
I think so.
Yeah, okay, this identity is true for any x in the world, especially it's true for 1 minus t, for example. Then you come back to x again, so it's 1 minus x, right? So it's true for 1 minus x. So when the right side send when x switch to 1 minus x, it become my 1 minus x squared minus 15 1 minus x. Okay, it's become 9x squared minus 2x plus 1, then minus 15, then plus 15x. Going to be 9x squared plus minus 3x minus 6, right?
Yeah.
And then
Yeah.
Skyline.
Yep.
So that's what it is. Then basically, this is a linear equation of those two numbers. Then you eliminate fx squared minus 3x plus 2. Or you can eliminate another one. That's okay. Okay. Just eliminate that one. Then you immediately get fx squared plus x equals 3x squared plus x minus 4. Then you have, okay, I will leave this page a couple of seconds so you can see it. If you don't, if you didn't take the note, then take note with it. We're going to have an exercise, pretty much same thing ask you to do. Okay?
Okay.
Are we good?
Not yet.
Are we good? There are actually several exercises in the end of the book doing the same trick. So, are we good, Skylar?
Yeah, I'm done.
Andy?
Yeah. I'm good.
Okay. So then you get F215 is because you can find x such x squared plus x equal to 215. Don't worry, you declare what the x is, right? Only that part. Then equals 6041. That's all. Okay, now we're doing one exercise. If f specify this, find F215. Okay, after this exercise, we do Who has the answer? Where is I think I saw something before. I'm so weird. Oh, there you go. Only I have the camera. Nobody has the camera.
I definitely don't.
I think Andy has the camera.
What was the question again?
That's it. Moving back. Done. Now it's done. Now it's gonna. Okay. Who has the trick? So give up? Or should we just leave it at homework? How about it? Let's see what I have with slides, okay? Liam? Skylar?
What?
I leave it as homework, okay?
Okay.
Yeah. You cannot find anywhere. In Google probably don't have it anyway. Okay? So the idea is you follow this step, okay? Almost exactly same. So you need to figure out the trick. Okay, leave it as homework. You spend like a minute in for it. Let's see, we still have a little bit. Cyclic function, like function can all we'll talk about this already. Then everything is that's it. Yeah, it's done with today already. Okay. So you can still stay like 5 more minutes if you like. I can check in 5 minutes. Otherwise, we can go in. Okay. I have we cover towards two things. So first, so you need to continue to do the problem in the chapter 7. The next time we're going to review chapter 8. Okay. Also, looks like I think if we're doing Thursday, probably we better doing another on Sunday. Okay, Thursday, Sunday is a good rhyme. Is that right? What do you guys think?
Yeah.
Yeah.
Okay,
Yeah.
I will talk to your daddy in the email. So, okay, good.
Okay.
Oh, everybody's still here. This is too heavy. I'm moving now. Bad. Anybody get the answer? Okay, we leave as, huh? William, you get it?
No.
No. Okay. We leave as a homework. I can give you a hint. Not sure it's working or not. No. So y minus x. I think mine. Oops. I think it's die on time. Okay, leave as homework. So remember a minute ago we were talking about which one has the square equal 1? Remember?
Yeah.
Let me see which answer, which question was it. I actually didn't really pay attention more. Then it's interesting. Oh, FF. Oh, 7-5, item 3. I say which is f compose f equal x. Y minus x was an example there, right? We need to using the function satisfy that to make I know exactly. Let me see. Huh. Anyway, whatever you want to figure out.
Can we get a hint?
Huh?
Can we get a hint?
Yeah, using something similar to y minus x. So we replace x by some kind of fx. That f should be searched by f and compose f x equal x. Because you can compose it back. That's what it is. Yeah, very similar. So we had it already. Just my screen is frozen. You can already go in there. Oh, maybe close this. Still not already frozen. I'm not sure why not going there. Something wrong with it. So using something else, using like we have a bunch of if you take the note, let me see. I must go in there. Let's go in there. See what happened. Huh? It's crazy. It's not going there. I think it's frozen somehow. Photoshop frozen. Unfortunately. Oh, that cool. Oh, I have to double click it. I'm sorry. Yes. You remember this page? That's what it is. This is the function you need to work on, okay? So that's what we're talking about. One. Skylight n minus. So those 5 of them will be one of them you have to use, okay? Got it?
Okay.
Yeah.
Okay.
Yeah.
Okay, what is it? We done? You everybody still here?
Yeah.
What's the who get the answer?
No one yet.
Yep. No one.
Okay. Oh, 7:30, 9:30, 10 o'clock already. Okay, we dismiss. Anyway, okay. I say good night to everybody now, okay?
Okay.
We are done. It's already 10 o'clock. Okay, I didn't realize it. Okay?
Okay.
Bye.
Bye.